Okay, let us start. What we discussed in previous session was like if we have two different object files which are to be linked together, and what are the different steps to be followed. Correct. So now when we really talk about uh, the steps, one major element would be like how the code would be organized, and second important part would be like how the symbol table from each respective file is going to get connected. Fine. So let us see like what happens if you have two different codes with same types of variables, or same type. I mean to say same name for that variable. So let me take C code. Okay, so let us first save this. Let us try to generate file. Okay, and now if I try writing this, I can see that some variables are added there. Okay, so I can see that I, J, K. Okay, main. Even try to see whether can we get ch2. Can you see ch? Okay, because the code we wrote was this. So we had ijk three variables. A and ch are local variables. That is the reason why only ijk is available, but a and ch is not shown because they are local ones. Now suppose there is another code written. Now I am giving name as 1. Now I am changing this. Now I am combining. I change name of the function. So this is my first file, and this is my second file. So difference is what? We have MIAN, here we have MAIN. Now we know that there is no call between the function, correct? But suppose if I give both the files for linking purpose. Now do we see any error there? No, warning because of only printf and whatever, like the remaining things. If I try to see now nm, now you will identify in both files we had ijk. So one instance of ijk is here, okay, which can be easily seen with a dot out. Then what exactly happened with the respective ijks? Okay, because we had two different ijks, so this was my code, correct? This was my code where ijk was variable, and similarly I wrote this one code. Correct. So like as there is no linking altogether, only the name was picked. And what exactly about this ijk? Okay, so let us say, let us go back to the file again, original file. Let us call this. Okay, now let me again generate executable. Okay, only warnings are there. So if I now see again nm.a.out, what happened with the ijk, which seem to be repeated there, correct? I can see that main and MIN is available here, correct? Main and MIN, but ijk is occurring only once in this case. So if I try to write this code, I do see that there are two different ways the output is printed. So this is values are this second one of the output, and this was something with respect to the output, because it might be picking it from local variables. Okay, what are the local variable? This might be an address picked or some garbage value picked for that ch when it was pushed onto the stack, because it was a local variable. Correct. In this case, we do see like, okay, let me add /n so that it would be easy for us to check this. So this will clear again our idea. Let us combine. Let us execute. Now you can see this was from your first code. When it got executed, some values were there. Then the function was called. MIN was called. And then it is printing from MIN. Now values for IJK. Okay. IJK seems to be okay. IJK and A. But what about CH? We are not able to see that CH. Okay. So let us make a small change again so that you can see whether it hasn't printed CH thing or it printed value of CH. So in this case, what I will do is I will write this so that we should be able to see, like there is no space between this, but we want to see some value for this %c for CH. Fine. GCC a.out. Now you can see that like there is nothing added here, correct? If I try to see the code, it is showing like this. So how exactly, where exactly we added that code? Dash dash dash. We added before and after. So total dash the equal to signs are 6. How many are shown here? 1, 2, 3, 4, 5, 6. And the values those were printed by us were 1, 2, 3, 4, and 5. But in this case, you can see it printed 1, 2, 3. This is 4 and this is 5. So some garbage value was picked for that A variable here from the stack. And for CH also some garbage value was picked. But later when it executed MIN, then initial R IJK, then again A. So A value again which was picked from stack now, the stack for MIN, correct? It printed 0 and it hasn't printed any value for CH. You can see that all those 6 equal to's are added there. Right. So similarly, if I try to do the same thing for my code, here So it should be clear in this case, like we wanted 6, na? Yeah. So 2 and 4. Now see, we can say that this V is printed for a character, but at later stage, no value was printed. It's like empty, a empty character. Like in TCS, you generally must have heard a terminology called epsilon, correct? Or epsilon, whatever way you call it as. Now, what is the importance of that part? What is the importance of that epsilon? Like you did, some of you did this course theory of computation twice. Rather, you did once in your bachelor's, and some of you are doing it this. Some of you did in bachelor's, and some all of you are, most of you are doing that course in this semester. So can you point out what is the importance of that epsilon symbol in the theory of computation? Is it having any value? Considering it could be a regular expression, it could be the language, it could be related to the string accepted. What is its importance? Why do you require epsilon kind of stuff? Okay, so let me show you one thing which can help you to understand that part too. So let us see whether we get some instructions added there. Let us go to main. So this was your main code, correct? Fine. And this was MIN. Now see how it is organized. Your first code was picked, MAIN, and in your, after combining both the object codes, first it displayed main and then it displayed MIN. Was it because we added this line like this, first this code and then this code? So if we change the order of this, both the files. Okay, now let us try to see, is there any change with the occurrence of main and MIN? Now see. So you can see now first MIN, then something else, then MAIN. Can you see the order change? With respect to how exactly you pass the commands for linking purpose. Because earlier when I had my compilation line or linking line containing this thing, rather, with this file to be first and then this to be second. So organization was all contents of first are displayed and then second is added as an a patch. Now when you change the order, whatever is first now, which was actually second file, is added first and then your first file would be picked. So that's how your object codes are arranged. Because it is not only talking about combining symbol tables, it is also talking about combining object codes too, because addresses would be changing. So suppose if you see this code, try to see what is the address of MIN. So let us see MIN. It is 1239. Correct? Let us keep this in mind. Now let us change the order. This was the order taken. So let us change the order like this. So let us see whether it is 1239 or something else. We are talking about MIN. Is it changed? Yes. So was this same? Was this same? What was the earlier one? 12 12 क्या था पहले? See, okay. Currently, let us see. Main का कितना है? What is the address for main? 1226. Okay, and the linking order I gave was 0, 1 and this. Okay, now let me reverse the order. Now I am having reverse, like the reverse one. So I have this to be first and then second file to be the second. So again, if I open, See what is value of min. It should be changed because your linking time addresses are also changing. See now it is 11CD, which was different. And if you recall, I talked about stack frame created for every function call. This function is responsible. Stack frame dummy, which creates stack for each and every function that you have in your code, and which would be adjusted accordingly with respect to whatever the contents of code are. Right. So if they have function call, then probably you may see frame dummy involved, inclusion of frame dummy. But if there is no function call at all, you may not see the same. Then how this organization is to be done? How will you organize this? The addresses are need to be changed. So can you combine two different source files? In what sense? Suppose, let me show you that through an example. Suppose this is your first file. Okay, and this is your second file. Okay, now what you want when you link together, rather, this should be added as a single file, paste, and below it, this is patched. So your code will be now this one. So your code will look like something like this. Correct? Because these are the local addresses added. While creating a object code, this file was having some addresses associated. This file also had some addresses associated with every line. But when they combined, their addressing style is changed because they are patched in part of some big code. Suppose this was your code generated. Okay, for an executable. Then somewhere this was patched. And then your remaining code. So your a.out is looking like this after linking these two different object codes. But it is only linking of the object code. What happens with the symbol table? Correct. Now both the codes had functions. Sorry, both the codes, whatever the code that I demonstrated you, are having ijk as variables. So when we refer to ijk, when printf is there. Okay, let us see this printf call. So it had these addresses. So some values are pushed into the stack. So ECX, EDX, EX is holding the value, whichever was given for the local variables ijk. Sorry, these are the global variables. Na? We had one A and then this was A and then we had CH. Correct? So ultimately, when we see this, when symbols are to be combined, so some renaming should be done internally. If you recall, I showed you like how the renaming is done for a label which is added as a part of your macro when macro is to be processed. But same thing can be carried forward with respect to every variable that you use this because this ijk is only for user to see. But when we do talk about ijk, you never will encounter ijk written here. So they are referred by addresses, which you can see here, or the values. Now, what exactly is happening there when we are talking about such cases? Some computation in respect of addressing is automatically done, which helps the linker rather to really work out part of the code. Whatever the ijk those we found. Correct? Because if I see my object code after linking, I never can find out ijk listed here anywhere. Can you see ijk somewhere? if I go to data section, let us try to see whether can I get ijk somewhere as a part of data. Okay, let us do this. Obj dump greater than p, gedit p, control F I. So see, so it would be taking. Okay, let us take k. This would be simple. Now you will not encounter variable k at all anywhere. Correct? Can you see k? This was part of one word, another word. Okay, now let us see this k. This was a variable that was declared, but how it will know like which k I am talking about? Correct? Which k I am talking about? Whether was it the k belonging to which file? So how do I preserve scope of it? Scope of that variable, which variable it belongs to, or which procedure it belongs to. When I say this, because I can see that, see even how the naming is done. They are added into BSS. Correct? Because now if I see, say for example, control, sorry, we should close without saving. So let us gedit, GCC -c nm 070921.o. Okay. Now let me do compilation of 01. So if I see this and this, can you see ijk in both cases? So when they are global, they actually are combined together. It assumes that as they are global variables, they are occurring only once, because when we combine both the files, okay, through the linker in this case, and whenever I do see like nm a dot out grep I. So this was one occurrence of I, which was for BSS. But then it doesn't have any information about the other I, because anyway it is what? A function. So let me complicate the process for a while. So let me not talk about now variable name. So let me talk about this MIAN. And let me add it here. So now let me remove this function call. Okay, let us compile this. This was done. This also was done. So there is no error for a while for us, correct? So if I see nm 070921.o, both the files are containing MIAN, correct? In this case, it is saying something about MIAN. In this case, it is saying something about MIAN. Now, when I try to link together, now let us see what happens. At the time of linking, it tells me a warning. Can you see some error there? Can you see some error there? No. Most of them are warnings. So that means like with respect to our habit, we do skip it. So if I write now nm dot out, how many times MIN would be occurring? So how will I know whether it is a symbol or a variable? because one case it was a symbol because it was a function name. In other scenario, it was treated as one of the variable. If I see this with less, see whether can you get min occurring here. It's not here. When you go below, you will identify that this min definition occurred. That means what? Whenever there is a global name occurring inside the code, then it is going to pick only once because considering that both of them are global. Now let me do the same thing with my assembly code. Sorry. Section dot data a dd10 b db. This is sample 0. Section dot text global main and rate. Fine. So this is saved. Section dot data a dd10 b dw20 section dot text global main rate. Fine. So right now, if I try to combine both files, then it would be a problem because occurrence of main would be twice. Okay, so that's why we would change this MIAN. Okay, so let us do this NASM dash APLF 3207 dash 09 dot ASM. Same thing. Yeah. So if I see now NM 07 dash 0921.0. Now see here at local level they seem to be considered correct. Now what happens when I try to link together? So GCC dash M32 07 dash 0921.0 07 dash 0921 underscore 01.0. And if I talk about now nm a dot out, let us try to find out where our local variables are. Can you see now they are added twice? Can you see they are added twice? Are you there?
Yes, sir.
Yeah. So what might be the reason now? So earlier it was not adding them together. Now it is adding them together. Earlier they were treated as global variables. Correct? Here when you add to data section, they are treated as variables. There was no concept of global or local. But now how we will identify which this A belongs to which code? Whether this code or this code. Both those are occurring and it is ordered one. Correct? So even if I write readelf see your ABCs. Sorry. See, now it separated it. The scope was defined. Okay, this was belonging to this file and these AB are belonging to this file in symbol table. So it is keeping that information. Am I right? Understood what exactly is happening here? Yes, please.
Yes, sir.
Now, I hope Lalit, you only asked this question, correct? What happens if you have same name occurring? Fine, on WhatsApp. I assume Lalit Gaikwad, na? Yeah. So, like we need some kind of mechanism to handle this. So this name may not be your primary key if I talk about databases perspective while you define, because there is definitely something added along with this, which is renaming that variable depending upon scope of that function. So that's what I wrote even with respect to your query. You have to rename one to protect scope of it. So that renaming is like somewhere, though it is showing us these symbols, renaming internally would be done for every variable that you use. This A and B will never occur in the code. They would be replaced by something else. Either it is the policy adopted by your linker, or it is the policy adopted by your translator itself. Every variable would be replaced. But then if your translator is doing this stuff, question would be what? What happens if my policy change is to be implemented? You can see like frame dummy is added there, which was for the stack. Correct. So definitely there would be difficulties when you are trying to design your own linker. So your major challenges would be what? How to combine two different symbol tables, how to organize the code. I showed you earlier only like how the code is organized, what are the first file name is as the command line argument for your command. Would be that code would be occurring first and followed by code from the second file, which is occurring as the command line argument number 2. Now furthermore, we need to handle if there is a function call, then how exactly the addressing would be done. So you will require now addressing for different four things, like what I showed you earlier. I showed you that ijk was occurring only once, and now here we can see that this a and b, whatever is shown over here, correct, is occurring two different times. So what exactly is happening? So if we are talking about a procedure, then the data addressing would be falling into different four categories. First is the caller would be permitted to pass arguments to the procedure. Whoever is the caller I mean to say the one who is going to call the function. The caller can pass arguments to the procedure. Will be permitting that. Then what are the local variables are? They will be allocated within procedure and would be freed before your procedure is going out, and they would be private for it. So in this case, this A and B would be private for this. This A and B would be private for this particular function. If there are local static elements, considering that data is stored at fixed location in memory. Okay, this again it needs to be handled. And lastly, global static. And this would be kind of fixed location memory, which can be referenced by different procedures. Now we need to have something as chunk of stack memory. How that stack memory will look like then, if at all we are talking about a stack. Correct. So we need to have some kind of structure in front of us, like how it will look like. Okay. So let us try to see this. Please hold over a minute. Now see this one. How exactly it would be handled? So there would be a stack, and for every function there would be stack frame created. So previous frame and then this new stack. So incoming arguments would be added here. Then your return address. Then old frame pointer because we need to go here, which would be stored with frame pointer register. Then you would be having local variables stored here along with the stack pointer register. This is lower address, this is higher address. And remaining part of the stack would be unallocated. When further there is again another function called, then this unallocated stack space would be given, and then again it will start like this only. There would be now the current frame would be becoming previous frame, and then your rest of the procedure call is supported by writing these incoming arguments, return address, old frame pointer, or through the frame pointer register, and so on. Correct. So that's how the information will be stored. So like you can see local variables would be added, stack pointer would be kept. There would be old IP instruction pointer with return address, old IP. When I say frame pointer, okay. So this is stored through the special purpose registers provided by your Intel architecture. For every architecture, there will be similar kind of process adjusted or added, which would be doing that whole stuff at that point of time. Correct? Correct. Now, whenever we are supporting this kind of stack usage for the function execution, we need to have some mechanism which would be creating the stack frames. 1 minute. Please hold. I have a call. So that stack frame needs to be adjusted accordingly. We need to have some procedure which would be creating the stack to support every function call, and that would be really mandatory in some case. Okay, and like if you see the code that is generated here, so though we are talking about only a.out, it would be applicable for every such kind of file format. Only changes would be what, depending upon the architecture that you are choosing, things would be adjusted. So what if I have more files added there? So let us do this. Let us create one more file. Now I'm adding some other name. Now this is my third file. So let me combine. Let me assemble first. Assemble. Oh, sorry. I gave, I think, name as C. Oh, my bad. 07-0921 underscore 02.c 07-09-21 dash 02.asm. Now we have this third file also added. So if I see nm 07-09-21.o, nm 01.o, and 02.2. So you can see that all three files are containing now AB. What happens if I link together all of them? .o 070921 underscore 01 dot o 07 dash 09 dash 02 dot o dash m32. Now if I write this nm a dot out pipe less. So let us try to see this. Again replicated, correct? Because it is it is a separate file. Now, but my frame creation code would be occurring only once. Because no matter how many such function calls are to be supported, the function call for creating stack frame would be used or created only once. That will get always executed. Correct? You will never find out that frame dummy occurring twice. And that would be handled by this kind of code. So you can see there are three. So suppose if I remove one from them, okay, let me show you first this. So see which are them, BP, BX and DX, correct? So let us remove one from it. Again see this, let us go below BP, BX, DX. Okay, so let us first delete this file and then generate this code. So it is showing me same thing, BP, DX and BX. Was it same there earlier too? BP, BX and DX. Was there any change with respect to the order? Try to see this. It is same. Then who is handling this? So was there anything related to some kind of stack frame creation? Because stack itself is one kind of array. And you can see that there are multiple things containing say array part there, correct? Which is handling that. Now these are the internal function names used by your glibc library. We don't know what they are. So until unless we do work on GCC source code, we would not be able to understand what exactly is how exactly these names are picked. But our goal is not to talk about how to scroll through or how to scan the code ultimately. Correct? Now the thing is, if it is the case, how exactly this data is to be organized in the symbol table? How will you keep this data? So you will require some information into your symbol table which will define scope of the same. Because when we saw that obj dump, sorry, not obj dump, but readelf dash s. Okay, let me first create this. Okay, readelf dash s a dot out pipe less. Now you will see occurrence of ABC, that those variables AB along with the scope. Each file is added there. Fine, and there will be multiple internal sections are added into your ELF file. So I will be sharing one document which in one of the class I shared earlier. Okay, what are the different sections? So let me show you that file which I will be sharing rather. Is my is my file visible to you? Yeah. So you have a section which contains this. Okay, and like some information is added with respect to your, our ELF file. What are the different names of the section? What they contain? Okay, important ones. So there are some predefined non-user section which we may not have to worry about. So the information would be added always into each and every executable that you have. Fine. So I will share this file with you. Okay, I hope you must have received the file. Okay, so kindly go through it once. We are not interested in creating executable like ELF, but ultimately, like suppose I'm going into going to work in say NVIDIA like company, then I definitely would be requiring such kind of file, which will be kind of guideline for me. What would be the kind of sections that needs to be added? Okay, so this is for only information purpose. Okay. So in next session, we'll be talking more about other important aspects related to uh, this combination of symbol table, what kind of treatment is to be given to the symbol table and so on. Fine. Okay, so there would be some kind of data and instructions referred. How this is handled with respect to what are the addresses that you may have. How the organization of bytes is done. Okay, because we already understood the little Indian and big Indian notation. Now, even we addressed like how the decoding or encoding, not decoding, but encoding of instruction is done internally whenever an object code is generated. We continuously rather in first initial sessions, whatever the task we did actually, we created a raw information for our linker understanding. So some of you might be really worrying about, are we going to only translate instructions using Intel manual? But actually you are going to create or you are going to use that information. So if you see read that linkers and loader book which I earlier passed to you. Okay, you can open page number 222-44. Okay, where you would be able to see exactly the name of the file or what we talked about mod rm. Okay, so let me show you that part too. Probably you can see this was from the linker loader book. You can see like we are talking about mod rm, sib, and a&d and like kind of correct displacement. So this it is talking mainly about architecture perspective, which we already addressed. Okay, through very brief, lengthy, rather not I should not say brief, but very lengthy sessions to understand how the translation is done at that side. And when it is to be linked, then our expertise of data structure comes into picture. Okay, so let me stop here. So I